today we're going to be talking about transformations of exponential functions. So we do know by now that our exponential function has this basic shape. We know that without any transformations, it has a horizontal asymptote at the x-axis, and we know that it has a y-intercept of 1. So we have the point 0, 1. The rest of the exponential function definitely changes as we change our b. So unfortunately, other than this 0, 1, I can't really give you any key points that you should be remembering. The only other thing that remains the same is our domain is xer and our range is yer such that y is greater than 0. Just as a quick reminder, if we have our f of x and it is being transformed to a f of k x minus d plus c, we do have all 4 transformations in here. So our a is our vertical stretch or compression. Our k is our horizontal stretch or compression. Sorry, I don't have a lot of room here. I'm definitely going to be short forming. Our d is our shift left or right. And our c is our shift up and down. Now, these are going to stay the exact same from our transformations chapter, and we are going to be learning to apply these to our exponential functions. Getting into our exponential functions here, we know that we have y is equal to b to the power of x. So if I were to write this with transformations in, I would have a times b to the power of k x minus d plus c. So please notice a few things. First thing I'm going to notice is that our a and our c are still out front or at the end, and our k and our d are actually in the exponent with the x. And that probably makes sense because even on the previous slide, as we were talking about it in terms of just function notation with our f, the k and the d were in the brackets with our x. So hopefully this is making sense to you. I did quickly want to go through one thing. So just to quickly remind you again, if we have a k of -1, we know that that means that we are having a horizontal reflection. Now we know because of our exponent laws that b to the power of -1 is the exact same as writing 1 over b. Now if I go ahead here and I draw the graph of y equals 2 to the x, then we know that this is the graph of y equals 2 to the -x. Now, this should also make sense to you because of this rule. We know that y equals 2 to the -x is the exact same as saying 1 over 2 to the positive x. So in our previous lesson, we talked about how a b that was bigger than 1 represents growth, so the red function that I have drawn here, and a b that is between 0 and 1 represents decay. One more quick point before moving on to some examples. If I have y equals b to the x, and I throw in a few transformations, but more importantly a plus c, we recognize that this is a shift up or down. And one major thing that we need to talk about is that if we have a shift up or down, our horizontal asymptote will need to change. I'm going to go through one example right now where I shifted this up 2 units. That would mean not only does my y-intercept change to be at 0, 3 instead of 0, 1, my horizontal asymptote also needs to change to be at 2 instead of at 0. This will change my range as well, so instead of y being greater than 0, I'm now going to have YER such that y is greater than 2. For the following example, it says that we need to state the transformations, the equation of the asymptote, and the domain and range. So our first example is 3 to the power of x plus 1 plus 2. I'm going to go ahead and I'm just going to list my A, K, D, and C. And we can fill in this information together so that we can write our transformations a little bit easier. So when I'm looking at my A, there actually is nothing. So it's important to recognize that in this situation, our B is equal to 3. So we have an A of 1. Now we can't have 0. That doesn't make sense. 0 times something is 0. So our imaginary A here is 1. Our k value is going to be in front of the x. So again, we have nothing and it's 1. Our d value is right here. Now remember, d is the one that's always backwards. So we know that it needs to say kx minus d. Now since ours says plus 1, we know our d is actually a minus 1. And finally, we have our c value here of 2. Now, we don't need to say anything for an a value of 1. Nothing has changed. Same with our k. For our d value, we do need to say that this represents a shift left 1 unit. Now again, it says plus 1 here, so that means left. It's a little bit backwards for our d. And our c is 2, so this means that we have a shift up 2 units. So we've stated our transformations. Next, we need to state the equation of the asymptote. Our horizontal asymptote, we can write as h dot a, is typically, we know, at the x-axis. So it's normally at y equals 0. Since we have this shift up 2, our horizontal asymptote is going to be at y equals 2. The next thing and the last thing that we need to talk about is our domain and range. So luckily, when we're doing this chapter, our domain will always be XER unless we have a specific word problem where we're talking about time or population where a negative won't make sense. And our range, which we know is typically YER such that y is greater than 0, is now going to change to be y is greater than 2 because of our shift up 2 units. So for this example, went ahead and threw all these transformations in for you. So I've got my A, my K, my D, and my C. Now before I start, I do want to mention that this B is 4. So this would automatically just produce a steeper graph than our previous example when the B was 3. Remember, the higher the B, the steeper the graph. So moving forward, we can see our transformations. I have a 3 out front, which is my A, which means that we have a vertical stretch by a factor of 3. So it's going to look a little messy here. Then I have my K, which is out front of the x inside of my exponent. So my K is going to be 1/2. Now typically a 1/2 would mean a compression, but we know that when we're dealing with K's, it's backwards. So this is actually a horizontal stretch by a factor of 1 over K, so 1 over 1/2, which is 2. Now again, all of these transformations are the same as the last chapter, so we are going through these pretty quickly because none of this is new. Our next shift is our D. Now when I look at this, I know that this is not factored, and so I need to factor it before I can actually find my shift. I am going to factor a 1/2 out of here, and so I'm going to be getting x minus 2, which means that my D is actually a minus 2. I would say that this was the most common mistake that I saw in our previous chapter. Students weren't factoring that out, and they were often getting the D wrong. So don't forget to factor out your K if it isn't already factored out for you. Now, a D of minus 2 does mean a shift right by 2 units. And finally, we have this plus 2 here, which means that we have a shift up 2 units. Now, I'm going to go ahead, I'm going to continue on with my horizontal asymptote. Now, normally, again, it's at 0. Since we have a shift up 2 units, it is also moved up to be y equals 2. My domain is going to stay the same at x equals, or xer, and my range is going to be yer such that instead of y being greater than 0, it's going to be y is greater than 2. In our final example for today, we are going to be sketching y equals 2 times 3 to the negative x plus 1 minus 1 using key points. So before we can start that, I do need to talk to you about b. So our b is equal to 3. That means that when we're doing our key points, we are going to be using 3 to the x as our y. So if I have an x of negative 1, 0, 1, 2, we'll just pick these. It doesn't really matter. You could have done negative 2 first, negative 1, etc. We're going to be going ahead and plugging that in here for my x to solve for my y. So 3 to the power of negative 1 is going to be giving me a 1/3. 3 to the power of 0 is going to be giving me a 1. 3 to the power of 1 gives me 3, and 3 to the power of 2 gives me 9. So these are the key points that I'm going to be starting off with, and then I'm going to be doing my transformations to these points. The next thing that we need to talk about is that, again, I don't have my k of negative 1 factored out here. So I am going to be rewriting this in fully factored form, so a negative x minus 1 before I go ahead and do my next step, which is to label or list all of my transformations. So first of all, I have an a of 2, I have a k of negative 1, I have a d of positive 1, remember it's always switched, and then I have a c of minus 1. Now here's where the magic is happening. Instead of doing all of these transformations on the graph like I used to, I am going to show you how to quickly just do it algebraically. So our original points, we're going to label x, y. That only makes sense. That's what we're calling them. Our new points are going to have these transformations applied to them. So our new points, we know the y's are going to be vertically stretched by a factor of 2, which means that we are going to need to be multiplying our y's by 2. And the other transformation that affects the y is our c. We know that our c is a shift up and down. Ours is a shift down 1, so we need to be subtracting 1 from our y's. Now we're going to take a look at our k and our d. These are the two transformations that are going to change our x values. So our x values are going to be multiplied by negative 1. It's a reflection in the y-axis. So we're going to have a negative x, first of all. Then we have a d of 1. That means a shift right 1. So we need to be adding 1 to those x values. This is definitely a skill that you're going to be learning, or I guess fine-tuning as you go along. And if at this point in time you need to graph all of the transformations separately, that is okay. So looking at this, my original point was negative 1, 1/3. My new point, I need to plug in my x of negative 1 into this equation. So I'm going to be getting a negative negative 1, which is a positive 1, plus 1, which is 2. And then I'll be plugging in 1/3 in for my y. So 2 times 1/3 is 2/3, minus 1 is going to give me negative 1/3. I'm going to go ahead and finish all of these points so that you can do it yourself and double check your answers. But negative 0 plus 1, and then a 2 times 1 minus 1. A negative 1 plus 1, and then a 2 times 3 minus 1. And a negative 2 plus 1, and then a 2 times 9 minus 1. Now, super quick, because I'm going to run out of time, you can see in black I have my original y equals 3 to the x, and in blue I've plotted the final points.